My name is Jonathan Levy. Thank you for the nice introduction, Alexei. And I'm going to talk about, I don't know how technical people are, so I'll try to kind of have a brief overview of everything. We can dive in. But the main topic of today is going to be security and interoperability and how we scale blockchains. I'm going to present it from the angle of somebody who is working with a lot of enterprises. So as Andrew said, we basically came into the blockchain from, so before I used to be an applied cryptographer. So I started cryptography, I was in the Israeli army, we did a lot of stuff that is to do with kind of channels and basically multi-party computations in the sense of like covert channels. Basically, you want to have some communications where you don't want people to know that you're even communicating anything. So let me just get there, and then I'll get into like what we are doing today. So this is how I started. I started with cryptography. I did a lot of stuff in finance. So I spent almost 10 years in finance. I was in Standard & Poor's, did credit ratings. We are trying to protect kind of transitioned credit information that is on the fly. I was in Barclays Capital during the credit crisis, built a lot of backend systems actually on the credit derivatives trading desk. Then Goldman Sachs, we wrote the global risk system. So it was interesting how I transitioned from kind of being an applied cryptographer. Our technology was acquired by S&P, then I moved to banking, but I still kept the mindset of a cryptographer in terms of data, accuracy, like basically having like highly sensitive data that is being transmitted, and you need to have a lot of computations that have to be reliable. Then finished the master's, went to Stanford, wanted to do another PhD. I dropped out of the first one, then I dropped out of the second one. But basically after 2 years or 3 years at Stanford, I got back to crypto, and then I started working on, I don't know, it was a cryptocurrency class. It was the first cryptocurrency class in Stanford with Dan Bonet, and then it's someone I just left. And what I tried to do, like my approach to blockchain was always, I want to look at kind of sharing information, sharing data, building systems, but I can be like the crazy cryptographer of like, you know, the cypherpunk, basically not trying to kind of decentralize everything, not to have a single point of trust, but at the same time, I always look at things still from a KYC, regulatory point of view, AML, and all the rules that you really have to deal with when you are working with real data in regulated environments. So that's just quickly. Now, the platform that we work to build is basically, it's Acera. The name is it came from hash commit reveal. The idea was basically to make a commitment on a blockchain and then later on reveal it. But if you look at exactly what we are doing, we ended up creating a layer that allows you access control that is blockchain agnostic. Meaning, if I want to be able to see who can see what and specify a policy of who can do what on a blockchain in a much more controlled way, we didn't want to do it baked into a chain. We didn't want to fork an existing chain. So we just ended up building the whole thing on top, and it is blockchain agnostic. The talk after me is going to talk about like deploying stuff in a blockchain, multi-cloud way. I'm just going to talk about like why we built it, and I'm going to focus on the actual problems that we're trying to solve. So, I don't know, you probably think like that, right? It's like, I don't know, 10 years now that we're talking about blockchains, and it's kind of nice, like we have a solution, everybody's looking for a problem. Sometimes people don't even care about the problem, which is cool. It's nice for research. But let's talk about what do you need to do when you want to go to like enterprise solutions, okay? So we started with kind of caring is sharing or sharing is caring, right? Let's all kind of, you know, sing the kumbaya, hold hands. We're all sharing everything. Now it's nice in this world where all I wanted to do back in the day with Bitcoin is we were trying to kind of prevent the double spending issue, right? So I had a coin. Let's say I have a token, number 17, and people are worried that if I'm going to be out of sync, basically I can pay to 2 different people, right? So we said, let's have a table, and every time I look at coin 17, I know the last owners. This is how the whole thing started. And then when I pay to like party B, if I try to pay again, coin number 17 is not mine anymore, right? This is how the whole world started. But now if you look at the blockchain today, we basically started with like sharing everything. And we assume that we can take the same technology that works very well for Bitcoin to prevent double spending and censorship resistance, and we believe that we can just come and harness it and then build my own permission chain. Okay, so I don't know if you, basically, we saw a lot of kind of institutions that it was basically mostly 2016 that realized that they built a prototype or a POC or a pilot, and then they ended up being kind of alone, right? It's like their own little blockchain that is not connected to everything. So let's look at like, why is it the problem, okay? The problem is that many blockchains are actually being, in regulated markets, are being developed and deployed in silos. And the reason is mostly regulations. So it was supposed to be animation, but it didn't work very well. No, actually, it does. So we know that there will be different types of blockchains. We know that we deploy blockchains for different needs. Sometimes it's going to be for financial asset transfer. Sometimes it's going to be for healthcare. In other cases, it's going to be some sharing. I don't know, we see like issues with reward systems. A lot of two-sided markets when you have like buyers and sellers. And we are thinking of, let's disintermediate the exchange. Right? So if I just want to buy from somebody, let's have a peer-to-peer network when I can just like transact with somebody directly without needing to go to, I don't know, the CME or any other exchange. But what happens, the colors basically represent a different blockchain type, right? So I can have like an Ethereum, a Bitcoin stack, a Hyperledger Fabric, Sawtooth, or whatever chain you're looking at. The problem is that you also have the separation of both different frameworks and different deployments, okay? So that's a big issue. So actually, the biggest problem that we have is that it's very difficult for me, not just to move participants, but to move data around, right? To actually let an event propagate to different blockchains. So I'm really siloed, okay? And then I need to maintain it. And then I'm exposed to different risks, right? So it's very difficult for people to manage these deployments. So why is it happening? Okay, I don't know how much time I have. By the way, I have no ability to control time. 10 minutes, good. So let's talk about why it happens, right? So people are not really malicious at nature, right? Basically, people try to take the permissionless blockchain, which was the Bitcoin and Ethereum, and all the kind of chains that are permissionless. They are built to basically tell you, to prevent kind of censorship resistance, right? So I would like to be able to prevent censorship. Nobody can come in and block people from accessing the network. So you're blocking a mining pool in China, somebody will do it in Thailand, then you see something in Korea, and people are going to move around, and as long as they have a synchronized node that basically downloads the latest ledger, you can go and validate the last block. I can always look at the signature of the last block, every transaction, and make sure that they are all valid. That was kind of the promise at the beginning, and it works, and it's actually great technology for this. Now, the regulated work started with, okay, we can't put everything in the open. This is why the whole thing started, right? Banks, financial institutions, regulated entities that actually care about your privacy cannot put PII, like personally identifiable information, on a blockchain in the clear. So putting the identity on a blockchain, let's forget about it. Putting a hash of the identity on a blockchain, possible, but it still leaks some information, right? So people started to think about, okay, we need to permission it. We need to kind of, at least at the very basic, I would like to know when I'm joining a network, who are the validators? Who are the miners? Okay? So, you know, like we work with permissionless and permissioned blockchains. So this argument is kind of funny for me sometimes because you can't compare them. Like, these are solutions. There are two different families of solutions that are trying to tackle different problems. Here we're talking about access control in terms of like, I don't want anyone to be able to kind of prevent access. And in regulated markets, I'm looking at, actually, I can share information only with people that I'm allowed to share information with. So if I'm going to give somebody access to my data, and it has some sensitive trade information, or identity about the client, the auditor, sometimes I'm not even allowed to share it with you, even if I want to. So in the permission space, you have, IBM was kind of one of the early starters. They started a consortium. They were part of a consortium called Hyperledger. That's 2015. I actually joined, I don't know, 2 weeks after I saw the first check-in to the public world. Oracle is adopting like a blockchain as a service, of course, Microsoft. So we see a lot of cloud providers, a lot of vendors that are joining kind of the permission space. Some of them give you like a platform agnostic kind of blockchain as a service. But if I'm looking at the regulated space and the problems we're trying to solve in the enterprise, is mostly about kind of IoT, financial asset transfer, like trade finance in different ways, right? Lending, borrowing, paying, trading, any kind of registered asset. And of course, if I'm looking at kind of the big kind of promise that was kind of how we started to kind of sing the kumbaya. It was the supply chain, right? Everybody kind of realized, thank you, that we can like have a state machine and the transitions, like the state changes, are going to be on the blockchain. Okay, so the problem that we have with all this problem is that nobody's talking. Like, and that's a real problem. Like, for different reasons, right? There are different like offerings, people offering you different cloud services, people offering you consulting services. Some people just have like specific hardware. Some people are trying to, basically if you think about it, right? Whenever you walk in an ecosystem, everybody has their own agenda. But effectively today, still, nobody's talking to each other. Like these blockchains are not talking to each other. Another thing that I think is important to note, all this stuff is going to stay. Like I don't think that Bitcoin is going to disappear, like even if it goes below 5K. Okay? I don't think that IBM is going to go away anytime. Oracle is really pushing a lot into, with a lot of kind of product offerings. You know, Intel is the, so there are a lot of players that, you know, they're not going anywhere. That's us, forget it. But let's talk about enterprise application requirements very quickly. So the biggest things that we saw over the last 3 years that people really needed, right? They wanted partition executions. They want to be able to come in and have different validators running different things. So we thought about how Ethereum works today, and in Ethereum, every validator needs to validate every transaction, which is a problem, especially in enterprise. Like if I have a subsector, or let's say I have the London trading desk validators, I don't need the New York trading desk validators to validate a trade. Maybe they need to be informed, but they don't need to execute the exact same contract and to validate it. So this gives you a lot of performance, and this kind of partitioning really helps you in terms of regulations. I'm going to go very quickly because I don't have a lot of time. Transaction history, that's clear. People want like an audit trail. If I look at permission and membership, this is exactly the stuff that I talked about in terms of KYC and all the other regulators, all the regulations and requirements. Another thing that is really key that people kind of forget is that post-trade or post-deployment, and once it's live, we really need to move data around. So we're not, like I think people were so focused on like going to production, and we work with a lot of kind of big players on getting, you know, all the checkboxes from the compliance departments and the competitors and the legal departments. And it is live and the stuff is traded and our platform is in production. But I think that the next step of what we do is going to be like to interoperate and move stuff around between these, data silos. So this is why we built what we've built, and we kind of extended it. I'm going to focus more on the problem still. So it's not exactly that access control allows people to censor you. Like the way we do access control, all the rules that we have are basically shared. So you know what the rules are, and people are actually executing the same policy. So whenever I want to block somebody, everybody needs to agree on that. Oh, I can have a policy. Let's say I need 51%. Or I would like to have a majority, but somebody can veto it. So the idea is basically not to think about, oh, these guys are permissioned, and now, you know, somebody can block it. Yes, of course, the network owner or the whole consortium can do it, but I don't want you to think about it, oh, access control, it means like the EOS kind of deployment, right? That whenever they think that somebody was breached, they just have a phone call, a video conference, and they block some, you know, addresses. So this is not the case, right? We are still open, we are still sharing this data, and we are still able to move stuff around, even with permissionless. Let's see how much time I have. This is an example. I don't know how technical people are, so if I see people squinting too much, I'll slow down. But this is like a nice deployment that combines a lot of things. So we actually, it used to be confidential up until like 10 minutes ago. I just didn't prepare a lot of slides, so I just took something from our spec. But effectively, if you look at what we have here, you're looking at a participant that requires an identity. The problem today, if you put the identity on the blockchain, you know, it's very, to be honest, like now we know that it's not even legal, so it's not an option, okay? So you cannot put an identity on a blockchain. At the same time, you don't want to have a central kind of authority that will come in and hold all the identities. So we use, in this example, we use the DID, so it's a decentralized identity. So I'm going to go and take my identifier somewhere else that I own, and then I come in with the DID to the use case. Then I'm going to come in to the blockchain. This is the second step. And I'm going to create a request. This is like an HCR DID kind of resolver. Then I'm going to come in and create my local identity for that blockchain, and then I'm going to transact with it. But at least here, it's different because I own my identity. I'm not going to come in, and it's not that the bank gave me, a user account number or Facebook allocated to me something. This is my decentralized identifier that I can move around different systems, and this works kind of cross blockchains. So that was very quick. I can talk, and I don't have time for questions, sorry, because I ran out of time. But if you would like, I'm still around. We can talk about more use cases and more specific stuff. But we do a lot of interesting stuff, even in enterprise, and there is a lot of room for innovation. So, yeah, thank you.